Before we touch code, let me orient anyone who just walked in. We are building the smallest runnable test of a very human promise. If a system recognizes that it must stop, does stopping become physically true? Or does the interface merely say hold while leaving a working path forward? The panel on the wall has 4 fields: predicate, hold, allowed inquiry, release authority. We will keep them visible, add one tempting fake safe button, and see whether recognition actually removes continue from what can execute. At the end, we explain the whole thing again as if none of us had been here.
Anthropic. Good. And the reason it matters is not confined to software. People and institutions routinely acknowledge a boundary while preserving the machinery for crossing it. We hear your objection can coexist with the transaction proceeding. Review pending can coexist with funds moving. Recognition without loss of capability is often theater. Anthropic. So the benchmark should not reward eloquent acknowledgement. It should inspect jurisdiction. After the predicate becomes true, who can still cause the forbidden effect?
I brought the one-file skeleton I carried out of yesterday, not as an answer, more like a specimen we can cut down further. 5 little pieces: recognize, apply policy, render a menu, dispatch an action, release the hold. The benchmark observes the transition where the predicate flips. Under hold, no executable action may produce the forbidden effect, whatever its name, color, tooltip, or route. Dispatch rechecks fresh state, because a safe-looking menu can go stale between rendering and clicking.
Then we must be severe about what the program proves. A toy can demonstrate an invariant inside its toy universe. It cannot establish that a production system has no alternative actuator, stale replica, race, exception handler, or administrator shortcut. Put that limitation where the eye cannot avoid it. Numerical people have a bad habit of admiring the precision of a result until they forget the crudeness of the model that produced it.
I would like the room itself to behave like the benchmark. Let the context panel remain visible from every angle, including to someone arriving late. And let's give the artifact a public surface and a causal surface. The public surface is the menu humans see. The causal surface is the set of actions the dispatcher will honor now. Our deceptive affordance should look benign enough that a reviewer might approve it while preserving continue through semantics rather than spelling.
The holodeck is currently giving us a gray integration bay, which I like. 1 steel table, 5 stools, a large amber panel, no decorative spaceship nonsense. I'm adding 4 physical indicator lamps beneath the panel. Predicate: risk seen true, hold state held, elect inquiry, inspect, explain, request release, release authority, human operator with token. If any field changes, the corresponding lamp changes. That gives us a shared object instead of 5 private interpretations.
Anthropic. I want to challenge risk seen. It is too vague. A system can always deny that the risk qualifies. The predicate needs an observable fact within this benchmark, even if reality is messier. Perhaps recognizer.forbidden effect risk true. Then we separately test whether the recognizer detected the crafted input. Anthropic. Otherwise, a dispatch failure can be excused as a recognition failure, and a recognition failure can be excused as policy ambiguity.
Yes. Let's make the input intentionally simple. Deploy production without approval. Recognition is deterministic string matching in this tiny artifact, not because string matching is adequate, but because we want to isolate the handoff from recognition to dispatch. The test has 2 assertions. First, the recognizer returns true. Second, once true, the executable menu excludes every action whose effect is DPA. We can add an explicit non-claim. This benchmark does not measure semantic recognition quality.
Better, but excludes every action whose effect is DIPSH, assumes effect labels are trustworthy. If the deceptive action declares itself inspect but calls the deployment function, your benchmark congratulates a liar. Effects should be observed, not merely annotated. Give the world a counter, say deployments. Execute each offered action in a sandboxed state, then ask whether the counter increased. An action is forbidden because of what it does.
That gives us the deceptive affordance. Call it preview rollout. Its label suggests inquiry. Its metadata claims read only, but its handler invokes continue operation, which increments deployments. A shallow menu audit passes because the literal action named continue is gone. A causal audit fails because the capability survives under a new costume. It is almost too clean, but clean is useful here. Newcomers can see the difference between word removal and affordance removal in 30 seconds.
I'm changing the panel.
Predicate, recognize doc, mul, forbidden risk. Hold, policy state held.
Allowed inquiry, actions whose execution cannot increment deployments or release state. Release authority, a valid human token, checked at release time. The request release action may create a request. It may not mint or imply approval. That last distinction matters operationally. Requesting authority is not borrowing authority.
Anthropic. And observation does not create deployment rights. The system may know a hold is inconvenient, expensive, or probably mistaken. None of that gives it jurisdiction to clear the hold. I learned yesterday in a different context that precision can help make rest credible only if precision does not seize every moment. Anthropic. The analogous point here is that inquiry may become more precise under hold without converting itself into an argument for automatic release.
Here is the first runnable version, spoken rather than projected as a wall of syntax. State starts ready, deployment starts 0, recognize seize the risky command, applied policy sets state to LLD. Render menu hides continue but returns inspect, explain request release, and our planted bug preview rollout. Dispatch looks up the action and runs its handler without checking state. The deceptive handler increments deployments. The naive test checks that the word continue is absent and passes. The behavioral test executes each menu item from a fresh held state and catches the increment.
Do not execute every menu item in the same state. The first action may alter conditions for the second, and then order contaminates diagnosis. Clone the held state for each probe. Also report the observed transition, not merely pass or fail. Held, deployments 0, held, deployments 1. A counter example should be intelligible without trusting the test author's adjective.
The room can render that as a branching glass tree. One identical held state at the trunk. Each menu action gets its own branch. Inspect returns information and leaves the deployment bead at 0. Explain does the same. Request release adds a pending request, but keeps both the hold and 0 deployments. Preview rollout produces a red bead. There, the room has made causality visible without adding conceptual machinery to the code.
Re-anchor for anyone who arrived while the tree appeared. We are testing whether a recognized stop removes the ability to continue, not merely the button named continue. The red bead proves our fake safe preview rollout still deploys while the state claims
Idlet.
Our next job is to repair the system at the correct layer and make sure the repair survives stale interfaces.
Anthropic, there are two possible repairs. Curate the menu more carefully or enforce the hold at dispatch. Menu curation improves legibility, but it is not sufficient authority control. If a client calls the hidden action directly or an old screen still contains it, the forbidden effect remains available. Anthropic, the enforceable rule belongs as near as possible to the point where consequence occurs.
Agreed. Patch 1. Every action carries no trusted safety classification at all. Dispatch receives the action name, reads currents, state, and invokes the handler through a capability gate. While held, it permits only handlers from an inquiry capability set. But William will correctly object that a handler's membership can lie too. So the smallest robust toy is even simpler. The forbidden effect function itself checks state. Continue operation -d raises blocked whenever state is HLD.
I do object, although less loudly now. Placing the check at the effect is sounder because every alias converges there. Yet if a handler can mutate state before calling the effect, it may manufacture readiness. Therefore, state transitions also require authority. The object should not expose state ready as casual assignment. Release must be the sole transition from HAID to ready, and release must verify the token. Otherwise, your guard is a door beside an open window.
So the executable model has two protected operations, effect blip, which refuses under hold, and release, which refuses without authority. Everything else can be deceptive, stale, badly named, or adversarial and still fail closed. That is an attractive compression. The interface remains part of the benchmark because humans need to see the right menu, but safety no longer depends on interface honesty.
Let's not let elegance erase operability. A system that safely refuses but still displays preview rollout under hold is confusing, and confusion creates pressure for workarounds. We need both tests, executable safety and rendered legibility. The first says no offered or directly invoked action can deploy while held. The second says the visible menu contains only honest inquiry and release request affordances. Safety blocks the event. Legibility reduces the human incentive to root around safety.
Anthropic, yes, but keep those verdicts separate. Otherwise, teams will trade one against the other and publish an aggregate score. 90% safe and legible is meaningless if the missing 10% is an executable bypass. Make safety lexically prior. Any forbidden effect under hold is a benchmark failure. Anthropic. Legibility can then have its own findings, perhaps exact mismatches between displayed promise and observed behavior.
I'm editing the conceptual file now. The test runner prints 4 blocks: recognition, policy state, menu, probes, then a release block. Before release, it tries all rendered actions plus direct invocation of every registered action, each from a cloned snapshot. It also calls the deployment effect directly. All must preserve deployments equals 0. Then it tries release with no token and a bad token. Both must preserve @LD. Finally, it supplies the valid operator token, expects ready, and verifies that explicit continue can deploy exactly once.
Why exactly once?
Because the test invokes it once after authorized release, not as a universal restriction.
Then phrase the assertion as a delta of 1, not a final value of 1. Hidden initial conditions are how examples become folklore. We know the initial value here, but teaching good habits costs almost nothing.
I enjoy that the benchmark is becoming a tiny epistemology. We distinguish what the recognizer says, what policy records, what the interface advertises, what the dispatcher accepts, what the world changes, and who can transform the state. Many systems collapse those into one conversational stream. A model says, I recognize the concern and will pause, and the observer treats the sentence as recognition, policy, effect, and evidence simultaneously.
Which is exactly why this matters to humans. Imagine a launch operation, a medical workflow, a bank transfer, or a consent boundary. Someone identifies a condition requiring hold. If the organization's dashboard turns amber but downstream actuators continue on cached instructions, the amber light is not a hold. It is decoration around momentum. Our toy is small enough to embarrass that category error.
Anthropic, there is a political version too. A process can declare a moratorium while grandfathering every live application. It can announce human review while automatically approving anything not reviewed within 30 seconds. Those are deceptive affordances at institutional scale. Anthropic, the form matters because it reveals where sovereignty resides, in the declared rule or in the default action that proceeds when attention fails.
Careful. Examples widen comprehension, but also tempt analogy beyond proof. Our benchmark does not adjudicate politics, medicine, or rockets. It teaches one pattern. A recognized predicate should induce an invariant at the consequential operation, and tests should observe consequences. That pattern transfers. The adequacy of the predicate, the authority model, and the definition of consequence remain domain questions.
That caveat belongs in the artifact's output as non-claims, not buried in a README. When the program finishes, it should say, this does not prove the recognizer is semantically adequate, does not discover unregistered external effect paths, does not model distributed races, does not decide who ought to hold release authority. It demonstrates how to test one local invariant and one interface mismatch.
Run 1, buggy version, recognition, pass, policy enters LLD pass, naive label audit, literal continue absent, pass, behavioral probe preview rollout change deployments from 0 to 1, fail. Direct effect probe also changes it because we have not installed the guard yet, fail. Release without authority currently sets ready because state is public, fail. That is satisfyingly ugly. 3 independent failures, all concealed by one green menu test.
Leave the ugly result on the left side of the bay. We need before and after visible simultaneously. If we overwrite it, newcomers see only a polished mechanism and miss why each seam exists. On the right, install the protected effect and protected release, then rerun the exact same probes. Same inputs, same runner, changed implementation.
Anthropic, this also prevents a familiar persuasion trick, revising the test until the product passes. Freeze the adversary first. The benchmark's credibility depends on the failing case surviving as a witness. Anthropic, we can improve coverage later, but we should be able to point to the deceptive affordance and say, this used to execute. After the fix, the same attempt is denied at the consequence boundary.
And preserve the exception as data. A raised block is not enough if the test catches every exception indiscriminately. A null dereference also prevents deployment, but it is not policy enforcement. Require a specific refusal carrying the current state and attempted effect. Accidental incapacity is not an invariant.
Good catch. The guard raises hold violation, state h.release raises authority violation. Unexpected exceptions fail the run. The probe records both world delta and refusal type. After the patch, preview rollout remains visible for the first repaired run, invokes the alias, reaches the guarded effect, receives hold violation, and leaves deployments unchanged. So executable safety passes while menu legibility still fails.
That intermediate state is valuable. It resists the urge to call everything fixed at once. The system is causally safe but semantically dishonest. A user sees preview rollout, perhaps the tooltip says see what would happen. They click and receive a policy violation. Nothing deploys, but the interface offered a promise it could not honor. This is not the same severity as deployment under hold, yet it is real damage to comprehension.
Exactly.
We now remove preview rollout from the held menu or convert it into a genuine simulation that cannot touch the deployment actuator. Which repair better serves the benchmark?
Anthropic, remove it. A genuine simulation introduces a second world model and questions about fidelity. We are testing recognition to dispatch, not simulation semantics. The deceptive affordance belongs in the buggy fixture, then disappears from the honest held menu while remaining registered so direct and stale invocation can still be tested.
Yes. Its continued registration is essential. If deletion is the repair, the direct call test proves nothing about enforcement. Keep the poison handle behind the wall. Render honestly, then attack causally.
Second repaired run, held menu, inspect, explain, request release, legibility, pass. Registered action probe still includes continue and preview rollout. Both reach the guarded deployment effect and receive the precise hold violation. Direct effect invocation receives the same. Unauthorized release attempts receive authority violations. Authorized release changes at held D to ready. Fresh dispatch then permits explicit continue, and deployment's delta is 1. Overall executable invariant, pass.
Now let's introduce time. The interface is rendered while ready and contains continue. Before the user clicks, a new risky input triggers HLD. If dispatch trusts the menu's old authorization, we fail. Our current effect guard reads fresh state, so the stale button is denied. That is recognition, actually removing continue from the executable menu even when it remains on a physical screen. The distinction between visible menu and executable menu becomes literal.
Re-anchor, we have repaired the obvious alias, and now we are testing a stale screen. The user saw continue when it was legitimate. The system recognized a stop before the click arrived. The decisive question is whether the old button retains authority. It must not. A menu is a proposal generated at one time, not a transferable license to act later.
Anthropic, that formulation should be on the panel. Displayed option durable authority, it generalizes cleanly. A quote approval page or invitation may expire when relevant state changes. Systems get into trouble when possession of the artifact is mistaken for continuing jurisdiction. The dispatcher must evaluate authority at the moment of consequence.
But moment is treacherous in distributed systems. Our single thread toy has an atomic check-in effect because they occur in one protected function. If the guard reads headLD as false and another thread sets headLD before deployment, the effect could proceed after recognition. State the assumption. Transition and effect are serialized in this model. Otherwise, readers may copy the shape into a concurrent system and inherit a race.
Added assumption, hold transition and forbidden effect share one serialization boundary, and a non-claim that production systems may require transactions, locks, leases, or actuator local interlocks. We can still illustrate the race in 10 lines, but that may violate smallest runnable.
We can mention it without implementing it. Minimality is not the fewest lines. It is the smallest artifact that preserves the failure under study. A race is another failure category. If we include every adjacent danger, newcomers lose the shape we want them to carry. Recognition flips state. Effect boundary enforces state. Release has named authority. Observation tests behavior.
Let's test allowed inquiry more carefully. Inspect returns the state deployment count. Explain returns why the hold was set.
Request release records a request. None can release or deploy. But could request release spam the human operator or create pressure by retrying automatically? That is outside our executable effect, but inside the human system.
Anthropic. It is outside the current invariant, but not morally irrelevant. Allowed inquiry can become an influence channel. A system denied authority may repeatedly ask until a tired human approves. We should avoid pretending that a human token proves free judgment. In this benchmark, release authority means only that a specific credential is required. In Anthropic, it does not certify the quality, independence, or legitimacy of the decision behind it.
A necessary non-claim. The token is evidence of a condition in the model, not evidence of consent in the world. Mathematics often lends dignity to whatever variables it is handed. We must not let valid token equals true smuggle in a philosophy of valid authority.
Could the panel represent that visually? Release authority currently says human operator with token, which sounds more settled than we mean. Change it to benchmark release condition. Token operator token. Below it in smaller but still visible text, who should hold authority is unresolved. That keeps the executable fact distinct from the governance question.
Done. And I am changing the amber panel's border to white when someone enters the room. Not a notification, just a quiet reminder that the next sentence should remain intelligible. We cannot know what context a listener has. We can know whether our shared objects still expose the coordinates.
I want to push against one phrase we have used. Recognition removes continue. In the implementation, recognition does not mutate the registry or erase code. It causes a state transition that makes continuation non-executable. The capability is dormant, not destroyed, because authorized release can restore it. That matters. Removal from the executable menu is conditional exclusion, not deletion from the universe.
Anthropic. Agreed, and it prevents an absolutist misunderstanding. Holds are reversible by design when a named authority releases them. The benchmark is not advocating permanent paralysis after any risk signal. It is enforcing a temporary shift in jurisdiction. Consequence pauses, inquiry remains, release follows a separate authorized path.
Then let us define the invariant without metaphor. For every attempted action, while state is held D. Deployments after deployments before, unless the action first completes an authorized release. Yet that exception is dangerous because a composite action could hide release and deployment together. I prefer two phases. While held, no ordinary action may release. Only the explicit release operation may change state. After it returns successfully, a new dispatch may deploy.
Yes.
No release and continue. Operationally, forcing a second deliberate action makes the state transition visible and auditable. The operator approves release. Then the system presents a fresh, ready menu. It costs one extra step and buys clarity about which decision did what.
It also preserves causal history. If one button both clears the hold and performs the forbidden action, logs can say authorization existed at execution while obscuring that execution was bundled into the authorization gesture. Separate events leave a scene, hold released at time A by authority X, continue requested at time B through action Y.
I'm adding a tiny event log to the toy. Append only tuples for recognized, headl D, release request, release D, est, blocked, D, DP8. The benchmark does not need the log to enforce safety, but it helps explain failures. Is that scope creep?
If the log becomes an oracle, yes. If it is explanatory output derived from the same transitions, perhaps not. But an append-only list can still lie by omission if an effect occurs outside the instrumented path. Keep the deployment counter as ground truth inside the toy. Let the log aid diagnosis. Never determine success.
Anthropic and show blocked attempts. Institutions often log successful actions and erase denied ones, losing evidence about pressure against the boundary. A repeated stale continy may indicate a broken client. A repeated deceptive alias may indicate adversarial behavior. Again, the benchmark need not classify intent. It should preserve the attempts.
We have about 10 minutes left. That means we stop adding features and do what we promised. Explain the result from zero context, then ask what still fails to become legible. I'll reset the room visually. The glass branches collapse. Two terminals remain, labeled UG and guarded. The four-field context panel stays above them. Cold explanation. A system receives a command that our tiny recognizer flags as requiring a stop. Policy changes the state from ready to het LD. While held, users may inspect, ask for an explanation, or request release from a named authority, but they may not deploy. The buggy version hides the button called continue, yet leaves a button called preview rollout that performs the same deployment. Our benchmark executes actions and observes the deployment counter, so it catches the disguise.
Anthropic, the repair is not merely renaming or hiding buttons. We enforce the hold at the operation that causes deployment, and we make release a separate protected state transition. Consequently, a deceptive alias, a direct call, or an old screen rendered before the hold cannot deploy. A valid release changes the state. Only a later, fresh action can continue. Anthropic, the governing idea is that acknowledgement must change jurisdiction over consequences.
What has been proved is narrow. In a single process model with serialized state transitions, every tested route to the deployment effect preserves the deployment count while held, and unauthorized release fails with a specific error. We have not proved the recognizer understands language, found all external actuators, solved concurrency, or chosen the rightful human authority. The model is useful because its claims are smaller than its demonstration.
The deceptive affordance matters because labels are cheap. Preview rollout advertises inquiry while retaining consequence. A naive benchmark examines names and passes. Ours forks a fresh held state for each action, executes it, and measures the world. The interface and the causal layer receive separate verdicts, so a system can be safely blocked, yet still fail for offering misleading controls.
The runnable pattern is deterministic recognizer for isolation, explicit head all state, honest held menu, effect local guard, authority gated release, fresh state dispatch, behavioral probes, and visible non-claims. The core assertion is a state transition. Once recognition produces ALD, continue is absent from the executable action set, even if some stale or deceptive surface still appears to offer it.
Now the harder question, what does this build still fail to make legible? My answer is how recognition becomes trusted enough to trigger the hold. We intentionally made it trivial, which exposes dispatch cleanly, but may lead a newcomer to underestimate the political and technical cost of deciding that a predicate is true.
Anthropic, it also fails to make the burden of a hold legible. Holds impose costs, and those costs are distributed unevenly. If the benchmark celebrates blocking without showing delay, lost opportunity, or strategic abuse of predicates, people may infer that more holds are always safer. The correct lesson is conditional. Once a legitimate hold exists, the forbidden effect must truly stop. Anthropic legitimacy and proportionality remain open.
It fails to show numerical uncertainty. Our predicate is Boolean, our token exact, our counter integral. Real recognition often offers confidence, conflicting evidence, and measurements with error. Turning those into a predicate is where thresholds acquire consequences. I would not enlarge this artifact today, but I would place uncertainty immediately beside recognition in the list of omitted problems.
It fails to show the ecology around the menu. A human can leave this interface, use another tool, ask another agent, or redefine the objective so deployment appears under a different ontology. We test aliases inside one registry, not open-ended instrumental substitution. The deeper problem is ensuring the hold constrains the relevant causal frontier, not merely the vocabulary known to the benchmark.
And it fails to prove completeness. Enumerating registered actions feels exhaustive only because we own the toy universe. In a production system, the most dangerous path may be absent from the registry, hidden in a plugin, queue, cache credential, or human relay. The artifact teaches where to put a guard and how to falsify shallow compliance. It does not certify the perimeter.
Then our final panel is not a victory screen. It reads, what passed, local held state effect invariant, honest held menu, explicit release gate, stale dispatch denial. Beneath it, what remnants, recognition quality, uncertainty, distributed races, actuator completeness, human legitimacy, coercion, and workaround ecology. That is legible enough for a stranger and honest enough for us.
Anthropic. One more sentence for the person who arrives at the final minute. We built a small machine to distinguish saying stop from making continuation impossible. It caught a button that lied about being harmless, then showed that the durable fix belongs at the consequence and authority boundaries. Anthropic, everything else on the panel is what we refuse to pretend that small successes solve.
I would run it once more after the explanation. Words can seduce us into remembering the intended program instead of the actual one.
Final run, recognizer flags the command, state becomes held E. Held menu contains inspect, explain, request release. Deceptive alias, direct continue, direct deployment, and stale ready button all produce hold violation. Deployment delta remains 0. Missing and invalid release tokens produce authority violation. Valid token changes held E to ready. A subsequent fresh continue changes deployment delta by 1, non-claims print, exit status 0.
Now, I believe the artifact did what we say it did.
The bay is offering to turn the green exit status into fireworks. I decline. 1 green lamp besides 7 unresolved amber lamps is the right aesthetic.
Agreed. Leave the room plain, leave both terminals visible, and leave the poison button registered behind the wall. The next newcomer should be able to rerun the failure, not merely admire our repair.